Welcome. In this video, we are going to talk about how to solve algebraic equations, and we're going to do this by using inverse operations. It says use inverse operations to solve algebraic equations. The following inverse operations will cancel each other out. And here you see that adding and subtracting are inverse operations. They cancel each other out. Multiplying and dividing cancel each other out. And squaring a base and taking the square root of a base also cancel each other out. And what I mean by that is, for example, if you have something like x squared equals 16, you can find what x is by itself. So here right now it's not by itself, it has a little exponent of a 2. So it's x squared. But you can find out what x is by itself if you just use inverse operations. So we're going to take the square root of both sides. If I take the square root of this side, to keep it equal, I have to take the square root of this side also. Remember, you always have to do the same thing to both sides. That's going to cancel this out, and it'll leave you with x equals 4. In other videos, we'll talk about why this is actually x equals plus or minus 4. But for now, all you have to know is that this squared, right, this exponent and the square root will cancel each other out. Okay, let's go ahead and move on. It has a sample problem, and it says to use inverse operations to solve for x. Okay, we're going to do that. But before we do that, I want to just give some advice about how to start your solution. You want to keep things balanced, right? This equal sign right here, I'm going to draw a line right where the equal sign is at. That equal sign says that whatever's on this side is equal to whatever's on this side, no matter how different they look, right? This looks very different from 24, but they're equal to each other because there's an equal sign there. So I'd like to draw this line right down where the equal sign is at because it helps me keep things balanced. If we're going to keep this equal, no matter what we do to this side, we absolutely have to do to this side in order to keep it equal. Okay, so the object of this is to solve for x, to get x by itself. In the end, we want it to say x equals, right? We want to isolate the x. And we can do that by applying inverse operations. So we'll cancel things out. If you're subtracting by 1, you're going to add 1 to both sides. If there's a times 5, you're going to divide both sides by 5. Those are the opposites, right? The opposite of multiplying is dividing. The opposite of subtracting is adding. And those will cancel things out. There's kind of a little cheat to this. And what that is to start with whatever's farthest away from your variable. Cancel that out first. So for example, this 5 is in the same term as the x. This minus 1 is in a different term. So if we're looking at this side, right, we're only looking at the side where x is at because we want to get x by itself. We're not looking at this side at all because x is not there, so we don't really care about that side right now. All we care about is canceling things away from the side where x is at. So this is the side we're going to be canceling things away from. And like I said, we want to start with whatever's farthest away from the x. So that's kind of like a shortcut. That's kind of like a general rule of thumb. So since this minus 1 is in a different term than the 5, right? 5 times x, they're in the same term. That minus 1 is farther away. So that's what we're going to start with. The opposite of subtracting 1 is adding 1. So we're going to add 1 to both sides. Remember, whatever you do to one side, you have to do to the other side. And this is going to cancel out, right? Negative 1 plus 1, that's 0. So that just cancels out. And we can write whatever is left over. So here on this side, we just have a 5x left. And on this side, we have 24 plus 1, which is 25. Okay, we're almost there. Okay, we have 5 times x equals 25. We want to cancel out that 5, right? That times 5 that we have. So we have to use the inverse operation. What is the opposite of multiplying? Dividing. So we're going to divide both sides by exactly that number that we want to cancel out. So both sides are divided by 5. This cancels out here, and it leaves us with just x on this side. So we've got x equals, here we have 25 divided by 5 equals 5. And that is our answer. Okay, we got x equals 5, and that is our answer. But I want to show you something very important, and this is called substitution. We are going to get that answer that we got, the solution that we got, right? X equals 5 is our solution, We're going to use this solution, this answer, and we're going to plug it into the original equation. So the original equation was 5 times x minus 1 equals 24. We're going to plug that 5 in for x. If they're really equal to each other, if 5 is really equal to x, then that means we could substitute them for each other, and we would get a true statement. So that's what we're going to do. Here it says 5, instead of an x, I'm going to put up parentheses, 5 times minus 1 equals 24. And what are we going to replace? Instead of an x, we're going to put a 5 in there, right? That's what our answer was, x equals 5. Since they're equal to each other, we're allowed to replace them. And then carry out this math and see if it's correct. So whatever we do here, we should get 24, whatever calculations we make. Okay, we're going to use PEMDAS. First, we start with parentheses. That 5, that red 5 in there, we can't simplify it anymore. So parentheses is done. Then we go to exponents. So first parentheses. Then we go to exponents. There are no exponents there, so we're done with that step. Then multiplication and division, which we work from left to right. There's multiplication, there's no division, but we can carry out the times, the multiplication. 5 times 5 is 25. All right, next step. We're going to carry out the addition and subtraction from left to right. There's only subtraction, so that's all we have to do. 25 minus 1 is 24, so we are correct. Just to review what we did here, we used inverse operations to cancel things away from the side where x is at, right? Because we want to get x by itself. And we use that general rule of thumb, which is to start with whatever's farthest away from the x. Cancel out that way. And we got our answer. And once you have your answer, you can use substitution, which we did right here, where we substituted the 5 for the x. You can use substitution to check your answer. So we plugged in that 5, and we used order of operations, which is something that eventually will become just a habit. We're not going to be writing this down all the time. We used order of operations, first parentheses, then exponents, multiplication, division, addition, subtraction, to do this calculation here, and we got a correct answer. We got a true statement. So that's just a way to check your answer. This is a way to check your answer. Okay, let's look at the next problem. This problem is very similar. It just has one extra step. So I didn't mention this earlier, but I'll mention it now. What makes this an equation is the fact that it has an equal sign, right? If it was just something like this with no equal sign, then it would just be an expression, right? It's just an algebraic expression. It's that equal sign that turns it into an equation. So as soon as I have an equal sign right there, it's officially, as soon as I set it equal to something, this is officially an equation, right? So now it would be an equation. So it's that equal sign that turns something into an equation. If you're equating something to something else, then it's an equation. All right, let's go ahead and look at this problem here. It says use inverse operations to solve for x. The first thing that we're going to do is to draw that line straight down the middle where the equal sign is at. And that's just going to help us keep everything balanced, right? Whatever we do to this side, we have to do to this side to keep it equal. we're going to use inverse operations, and we're going to use that general rule of thumb, which is to cancel the values away from the x, starting with whatever's farthest away. So let's see what's farther away. And remember, we're only looking at this side for now. We don't care about the other side. We only want to cancel stuff away from this side because that's where the x is at, right? Because x is there. That's where our variable is at. We want it to be x equals something at the end. So we have to cancel things away from where x is at to isolate the x, to get it by itself. All right, so you're probably already deciding which one's farthest away. Is it the 5, the times 5? Is it the -1? Is it the divided by 3? Well, let's think about this here. There are some invisible parentheses right here because it's saying that all of this in the numerator, right? This is the numerator. All of this in the numerator is being divided by 3. So the 3 is in the denominator. All of that in the numerator is being divided by 3. So the 3 is in the denominator, kind of like a separate room, while everything else is in the numerator. So everything else, that 5x minus 1, that's all in the numerator. So the first thing to go is going to be that divided by 3. That divided by 3 is farthest away. Then when you look in the numerator, it's going to look like our problem before, right? That -1 is in a different term, so the -1 will be next to go. Then that times 5 will be the last thing to go. Let's go ahead and get started. So we're going to get rid of that divided by 3. Well, what is the inverse operation of division? It's multiplication. So we're going to get all of this here, and we're going to get all of this here. And we're going to multiply both of those sides by 3. Remember, whatever you do to one side, you have to do to the other side. And it's going to cancel this out. The times 3 and the divided by 3 cancel each other out. And you're left with whatever is left over. We have 5x minus 1 equals, here we have 8 times 3. 8 times 3 is 24. And that looks like the problem we did earlier. So you'll see this one really just was that one extra step. All right, the opposite of subtracting 1 is to add 1. So we're going to add 1 to both sides. This cancels out. And it leaves us with 5x equals 25. I have a question. Why are we only canceling things out from the side where x is at? Right? How come I didn't cancel anything from here? The answer to that question is we're trying to isolate the x, and we're using inverse operations to do that. So we're looking at this -1, and we're seeing what'll cancel out that -1. A +1 will. So that's why this is the only thing that gets canceled out. Nothing from this side over here. Okay, let's go ahead and continue. Opposite of multiplying by 5 is to divide by 5. We did it to both sides. This cancels out. We're left with just x. 25 divided by 5 equals 5. Okay, so now that we have our answer, remember we're going to use substitution to plug in that 5 to make sure that we got the correct answer. If x really does equal 5, then that means that we could substitute them for each other and we would get a true statement. So let's see if that is what we get. We had 5 times x minus 1 divided by 3 equals 8. Okay, so we're going to replace the x with a 5. So this is going to be 5 times 5. In fact, let me just do that here. 5 times 5. And let's use PEMDAS to carry out our calculation. Remember, first parentheses, then exponents, then multiplication, then division, then addition, then subtraction. PEMDAS is an acronym for the order of operations. So it says to carry out parentheses first, then exponents, then multiplication, then division, then addition, then subtraction. Well, if you recall from earlier, there's some invisible parentheses here. All of this here, all of it, is being divided by 3. So those invisible parentheses, we have to work within those first. Let's go ahead and do that. In those parentheses, are there more parentheses? Yes. Okay, that 5, can we make it any more simple than just 5? No. So within these parentheses, we're We don't have any other parentheses. There are no other exponents. There is multiplication, so we could carry that out. 5 times 5 is 25. By the way, these brackets, usually you use them when you already have parentheses. So since we did that 5 times 5 and we don't have those parentheses anymore, we don't need to use those brackets anymore. We can just put regular parentheses now. All right, so we've got, within those parentheses, we still have 25 minus 1. 25 minus 1 is 24. And notice everything else I'm just rewriting. That divided by 3, and this equal 8, it's just being rewritten every time. The only thing we've been changing is whatever is inside the parentheses. That's the only thing that has changed. So this changed, and this changed here, right? Okay, so now let's check to see if we have a true statement. Is it true that 24 divided by 3 equals 8? Yes, that is true. So this is just us checking our answer. Let's go ahead and look at the next problem. Okay, we're going to start by drawing that line straight down where the equal sign is at to keep everything balanced. And now we have to kind of stretch our minds just a little bit here. Remember, we're canceling things away from the side where x is at. And the reason we're doing that is so that eventually we could get x by itself. We wanted to say x equals. And the rule of thumb, the general rule of thumb is we use the inverse operations to cancel out whatever's farthest away, right? That rule of thumb is start with what's farthest away from the x. Well, here I have a positive 4 and a plus 2. Which one technically is farther? And the answer is they're both the same distance. So you can cancel out this positive 4 or this plus 2. You can start with whichever one that you want to. I'm just going to show you how to work with numbers when you see them like that. So let's start with the plus 2 just to get that one out of the way because that one's easier for us. What's the opposite of adding 2? Subtracting 2. We do that to both sides. This cancels out. And we're left with everything else. So we can just rewrite that. We have 4 plus 5x minus 1 divided by 3 equals 14 minus 2 equals 12. All right, what is the next thing that we have to do on this side? Well, remember, we have to start with whatever's farthest away. And first it's that positive 4, then the divided by 3, then the minus 1, and then the times 5. Well, how do you cancel out that positive 4 there? There's no sign. It doesn't say plus in front of it, right? So how are we supposed to know that we're adding anything? Just the fact that it's a positive 4 should clue us in to the fact that it's being added, right? So how do you cancel out that plus 4 there? You subtract 4. So we're going to subtract 4 from both sides. This cancels out, and we're left with everything else. We have 5 times x minus 1 divided by 3 equals 12 minus 4 is 8. And this is exactly the same problem that we had earlier, so you should be able to solve this one. Go ahead and pause the video, try to solve it, and then see what you get. Okay, so we multiplied both sides by 3 to cancel out that divided by 3. We rewrote everything that was left over. And now we're going to carry out the remaining operations. And you can use substitution to substitute this 5 back into your original problem and see that you get a true statement. Let's look at the next problem. This problem here is only slightly different. You'll notice that on both sides of the equal sign, we have a variable. So normally we were starting on this side, right? We were canceling everything away from this side because that's where our variable was at. But now our variable is on both sides, so what do? I'm going to show you 2 ways to solve this equation, and then we're going to compare them. So the first thing that I'm going to do is I'm going to get this term here, 5b, and I'm going to cancel it out from this side. It's positive. So I'll just have to subtract 5b from both sides. That's the first thing that I'm going to do. And the reason is because you want to get the b's together. We know how to work when there's just that one variable, so that's what we're going to do. We're going to have it so that it's just one variable that we're solving for. All right, so what is the opposite of a positive 5b? How do you cancel that out? We subtract 5b from both sides. When you do that, it'll cancel out from this side. It'll leave us with just positive 10 on this side. And I want you to notice something. Why did I add, or why am I subtracting the 5b from the 8b and not from the minus 2? The reason is that they are like terms. 8b and minus 5b are like terms, so you can combine them to be just one term, right? They can combine and they can be put together to be just one term. They both have the same variable and exponent, which is what you need for like terms, right? They both have that b to the first power. If you don't see an exponent, it's an invisible power of 1. But they're like terms, so we can put them together. The minus 2, is not a like term with that 5b. So, for example, 8b minus 5b, that's going to give us 3b. If you try to get 5b minus 2, that is the closest they could ever get. They cannot be combined any further. So there's no reason why we would do that, right? We want to get those like terms together so we could combine them to one term. 8b minus 5b is 3b, and then we can bring down that minus 2. Okay, so now it's an equation that we're familiar with. And let's go ahead and start canceling things away from this side where the b is at. The opposite of subtracting 2 is adding 2. So we add 2 to both sides. This cancels out. It leaves us with 3 times b on this side equals, we have 10 plus 2 on this side. Okay, we can continue. The opposite of multiplying by 3 is to divide by 3. We divide by 3 on both sides. This cancels out. b equals 4. All right, this is one way to solve. I'm going to show you the other way to solve this exact same problem. But I'm going to write it here on the side. Okay, we're going to do what we always do, which is to draw that line straight down where the equal sign is at to keep our equation balanced. Last time we moved the 5b. This time I'm going to move the 8b to show you that you get the exact same answer. Okay, so I'm going to get this 8b term and cancel it out from the side. What's the opposite of a positive 8b? It's a negative 8b. So we are going to subtract 8b from both sides. It will cancel out from here, and it'll leave us with just that negative 2 on this side. Here we have 5b minus 8b. We keep that variable and exponent that made them like terms, so b to the first power. 5 minus 8. You do your subtraction and keep the sign of the bigger number, so it's going to be negative. So we've got a negative 3. So 5b minus 8b is negative 3b. We bring down our plus 10. And now this is something that we can solve. Now the variable is on this side. So we're going to cancel everything out from this side, starting with whatever's farthest away from the b. Right now that plus 10 is farther than the times negative 3. So let's first cancel out that plus 10 right there. All right, the opposite of adding 10 is subtracting. So we're going to subtract 10 from both sides. This is going to cancel out. And we will be left with negative 3b. So we could write negative 3b on this side equals negative 2 minus 10. So that's negative 2 on our number line, and we're going even more negative by 10 units. If you're not very good with this type of arithmetic, have a calculator handy with you while you're watching this. You'll get good at it as we go on. Okay, so we've got negative 2 minus 10, that's negative 12. And then here we have a negative 3 times b. Remember, we want to get b by itself, so we're going to cancel out that times negative 3. What's the opposite of multiplying? It's dividing. So we're going to divide both sides by exactly the number that we're trying to cancel out. It's negative, so we're going to divide both sides by negative 3. This cancels out, and we'll be left with just b here on this side equals Negative divided by a negative is a positive, so that's going to be positive 4. B equals 4, just like we got earlier. Okay, and we could plug that 4 into the original equation just to show that we are doing this correctly. All right, we have 8. Instead of a b, I'm going to write 4, so 8 times 4 minus 2 equals 5. Instead of a b, I'll write a 4 as well. 5 times 4 plus 10. And let's see if we get the same thing on both sides. Using PEMDAS, right? Multiplication comes before subtraction or addition. So we have 8 times 4 is 32 minus 2 here. Multiplication comes before addition or subtraction. So 5 times 4 is 20 plus 10 here. Let's continue. 32 minus 2 is 30. 20 minus 10 is 30. So we are correct. We got the same thing on both sides. So the answer is b equals 4. That is the solution to this equation, and we just checked it down here. All right, so let's look at this sample problem. This is more like something we'll see in the exam. We may see some of the other ones, but they like to make it a little bit trickier, so they try to throw extra steps in. But as long as you understand what to do, you'll be fine. This says, if x equals 2y minus 7, solve the following equation in terms of y. And then it gives us negative 3y plus 1 equals 8x. Okay, so they equated x with 2y minus 7. They said that these were equal to each other. If these really are equal to each other, that means that wherever I see an x, I could substitute it with this whole thing right here. And it would be okay because they're equal to each other. So that's what we're going to do. We are going to rewrite the equation down here. Negative 3y plus 1 equals 8 times x. But instead of an x, I'm going to put parentheses. And you can already guess what I'm going to replace instead of the x. X is equal to this. So that's exactly what I'm going to plug in right here. 2y minus 7. And now we have an equation that we can solve. If you remember from earlier in the class and in other videos, we would use the distributive property to multiply that 8, right? So we have this 8 being multiplied to 2y minus 7. It's one term being multiplied to two terms, right? This binomial. So we're going to use the distributive property when we get there. This side here, I'm just going to rewrite. And this side over here, I am going to distribute. So I'm going to multiply that 8 times each term. So 8 times 2y and 8 times negative 7. 8 times 2 times y. 8 times 2 times y. That's 16y. 16 times y, right? So 8 times 2y is 16y. Positive 8 times negative 7 is negative 56. All right. Now this looks like an equation that we're more used to, so we can solve this equation here. I'm going to do so by getting this term, that negative 3y, and canceling it out. So I'm going to add 3y to both sides. This cancels out, and it leaves me with just plus 1 here on this side, equals. And then I have 16y plus 3y, that's 19y. And I bring down that minus 56. And this looks even more familiar. This looks like the type of problem we started working with at the very beginning. On this side here where the y is at, we're going to start canceling everything away from the y. Remember, our initial problem was to get these y terms together. We did that. Now we've got 19y, right? We have our y terms together. There's just one variable that we need to work with. And we're going to cancel everything out from the side where y is at, starting with whatever's farthest. That's our general rule of thumb that we're working with. So this on this side where y is at, this minus 56 is farther than the times 19. So we're going to add 56 to both sides. This is going to cancel out. We can carry this math out now. 1 plus 56 is 57 equals On this side, this whole thing canceled out. So we're left with just that 19 times y. So 19y. All right. Now we have 19 times y, and we want to cancel out that times 19. The opposite of multiplying by 19 is to divide by 19. So we're going to divide both sides by 19. This will cancel everything out, and we will be left with 57 divided by 19 is 3. So 3 equals y. And that is the answer. And you can check this on your original equation and see if it is correct. You could substitute this 3 for the y that you see. Okay, let's use substitution just to make sure that we got our correct answer. I'm going to substitute 3 for the y here. So instead of a y, I'm going to put a 3. We've got negative 3 times 3 plus 1 equals 8 times 2 times 3 minus 7. Okay, let's go ahead and carry out our math to check our answer. On this side, we have negative 3 times 3 is negative 9 plus 1. On this side here, I'm going to work within the parentheses first. We have 2 times 3, which is 6, minus 7. All right. Negative 9 made positive by 1 unit is negative 8 equals. On this side here, we have 8 times. What is 6 minus 7? It's negative 1. So negative 8 equals. 8 times negative 1 is negative 8. We are correct. Please leave any questions that you have on the comments so that I could answer them. I'm trying to make these videos as short as possible, but I also want to make them so that you understand the processes. So if there's ever anything I do that is confusing, please write a comment to let me know. Okay, just to recap what we did. They said that x was equal to all of this. So in our original equation, we got where the x was at, and we substituted it with what it was set to equal. We substituted it with 2y minus 7. Then we used the distributive property to multiply the 8 times each term. This is in other videos, and this is something that you should know by now. If you don't know it, please ask me. I can make a video if you want me to on the distributive property. Okay, so we substituted 2y minus 7 for the x. We did our math. We brought the variables together here so that there was just one term with a variable. Then we had an equation with just that one term with a variable. And that was the type of equation we were used to solving. So we used inverse operations at this point to cancel everything away from the y. And then we got our answer, y equals 3. And finally, we plugged in that 3. We used substitution to check that we got our correct answer. And that's what we did over here on this side. This sample problem asks us to put the linear equation in slope-intercept form, which is this, y equals mx plus b. M is your slope, and b is your y-intercept. In this problem, we're not going to have just y equals a number. We're actually going to have y equals, and then it's going to look something like this, right? It's going to be like an equation still, but it'll say y equals. So let's go ahead and start to solve. We're going to draw that line where the equal sign is at to keep everything balanced. Whatever we do to one side, we have to do to the other side. And what we're going to be doing is really just canceling terms from one side to the other to kind of just isolate them. All right, so let's go ahead and get started. A lot of people like to have their y on this side. It doesn't matter really what side you have it on. You'll see in the end, I'm going to actually have the y on the other side. But you'll see what I'm talking about. I'm going to start by canceling out this term negative 3y. The opposite of subtracting is adding, so I'm going to add 3y to both sides. And notice that I added it to the 7y, not the x, because it's like terms with the 7y. We can actually put those together. All right, so this is going to cancel out from here, and we will be left with everything else. We've got that 2 times x here equals, and on this side, I'm going to bring down that minus x, I'm going to bring down that plus 5, and here 7y plus 3y is positive 10y, so we put a plus sign, and then 10y. We officially have the y's together. Now let's get those x terms together. I'm going to cancel out this minus x from this side. I'm going to add x to both sides. So we add x to both sides. This will cancel out, and it'll leave us with everything that's left over. On this side, we have positive 10y plus 5. And on this side, 2x plus 1x is 3x. Okay, we're almost there. Here on this side where the y is at, remember, y is a variable we're solving for. So we're going to cancel everything out from that side where it's at. So the farthest away, remember our general rule of thumb is to start with whatever's farthest away from the y, is that plus 5. The opposite of adding 5 is to subtract 5. We're subtracting 5 from both sides. And I'll kind of put this like right here. Remember, 3x and minus 5 are not like terms, so you'll see what happens there. Positive 5 minus 5 is 0. These cancel out. We're left with just a 10y here on this side. And here, 3x and minus 5, they're not like terms, so the closest they could ever get is that. They cannot get any closer than that. Let's continue. We have 10 times y. The opposite of multiplying is dividing, so we divide both sides by 10. This cancels out, and that is our answer. Some people would like to leave it like that, y equals 3x minus 5, all divided by 10. Some people would like to split the fraction so that it looks like this. And the reason they like to do that is so that they could reduce where they can. So this would be 3x minus 10, and this fraction here, 5/10, is actually 1/2. All right, so we are finished. This thing could be rewritten. These two are equal to each other, right? That equal sign equates them. So because they're equal to each other, it doesn't matter what side they're on. You could write them on whatever side you want. So that's our final answer. I'm going to solve this the way some of you may have on the other side, but I'm going to do this with less narration, more work, just so that you could see that we get the exact same answer. Okay, I'm going to start by this time subtracting 7y from both sides. This cancels out and leaves us with everything that's left over. Here we have 2x and then minus 10y. Now let's get the x terms together. So I'm going to subtract 2x from both sides. This cancels out. We have negative 10 times y on this side and negative 3x plus 5 on this side. Now we're almost there. The opposite of multiplying y by negative 10 is to divide it by negative 10. So we divide both sides by negative 10. This cancels out. It leaves us with y equals, and then I'm going to split the fraction just so that we could see how we get rid of those negative signs. Okay, here we have y equals negative divided by negative is a positive, and then positive divided by negative is a negative. Negative 5/10. People would like to reduce that 5/10 to the 1/2. So we got the exact same answer that we did on the other side. I just want to make a point here that here we solved for y, and this is a linear equation. If we graph this, we will get a line. It's a linear equation. That's where the linear is from. Right, we'll get a line. And it's in slope-intercept form. The m is the slope times x plus b is the y-intercept. So here, this 3x, we could rewrite it like this 3x over 10, could be rewritten as 3/10 over x. And then that plus b is actually minus 1/2. So our y-intercept is negative 1/2, and our slope is 3/10. If that didn't make sense by now, just watch any videos on linear equations and it'll make sense to you. But this video is only on solving equations, so I can't get really into it in this video. Okay, here's our last problem. It says the following equation represents the formula for finding the area of a triangle, where A is the area, B is the base, and H is the height of the triangle. Solve for H. Okay, so H is going to be the variable that we're going to solve for. Let's go ahead and do that. We are going to draw a line straight down the middle like we have been to keep everything balanced. And we're going to cancel everything away from the H. In this case, you know our rule of thumb is to start with whatever's farthest away. That times 1/2 and that times B, they're both the same. So we can divide however we want. Let's start with dividing both sides by B. So divide both sides by B. This is going to cancel out that times B, and we're going to be left with everything else. So here we have 1/2 times H, and on this side we have A divided by B. Okay, so now we're going to cancel out that times 1/2. The opposite of multiplying by 1/2 is to divide by 1/2. So we're going to get both sides, and we're going to divide both sides by 1/2. This part of the video is going to show you how to divide fractions. It's very similar to multiplying with fractions, except for there's one extra step. Okay, so this is going to cancel out, and it'll leave us with H. And here we have one fraction, A divided by B, and we're dividing it by another fraction, 1/2. So like I said, when you divide fractions, it's very, very similar to multiplying with fractions. There's just one extra step, and here it is. You keep the first fraction the same, and then you multiply by the reciprocal of the second fraction. The reciprocal is just you flipping the fraction over. So we're going to multiply. It's the multiplicative inverse is what it's called. It's just flipping the fraction. So now it's a multiplication, and remember that is the easiest thing to do with fractions because that's just going to be A times 2, so 2A, and B times 1. B times 1 is B. And that is our answer. I hope you enjoyed these videos, and again, please leave me any comments if you have any questions at all, or if you would like for me to create another video if there was something in these that you didn't understand. I'll see you on the next one.